In this example, we want to see how many ways we can make car plates. If we pick 3 first places to be letters from the English alphabet and then 3 more to be digits from 0 to 9. So I wrote an example over here. YAY1, 2, 3 will be one example. So let's see what we're trying to do here. We are not going to list all the possibilities that we have. For the first place, for a letter, we have 26 options. And then for each one of these options, we're going to have 26 options more because nothing says that we can't repeat letters. And then for each of them, 26 more. So that's really not doable. But we can just reason what are the options in each case. We'll say for the first case, we have 26 options. For the second case, we have 26 options. For the third case, we again have 26 options, and then they come 3 that are numbers that have to be numbers between 0 and 9, and nothing says that we can't repeat them. So we have 10 options for each of them. So the question is how we put them together, and this could be intuitive for you. Let's say we were going to make a huge tree diagram, so with the 26 options for the letters A, B, C. I'm not going to do it here. I'm just going to give the idea, and then the last one Z. So here we're going to have 26 branches. So for each one of the branches, they're going to open up 26 branches more. So A, B, blah, 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 up to the last one. So in this second line of branches, we are going to have 26 for each one of the ones we had before. So if we look together at the possible combinations for 2 letters, like of the type AB or HM, these are going to be 26 times 26 options. Let's think about the branches again. Each of the options, if we just stop after the second step, is going to be, let me use a color over here, going through a first choice and then some second choice, like first A and A B. And because for each branch, for each node that we have at the end in the second column, so all the things we have over here, and this is huge, we are going to have exactly one way of getting here. So for instance, if we, I don't know, here, let's say at some point we have an M here that is coming from the letter H here. Yeah, so that's one option here. That's the option HM. So indefinitely what we need to count is how many things we have, how many leaves we have in the second of our branches. So we have 26 times 26. So what I'm saying here is that we need to multiply the options we have in the first space times the options we have in the second one to be able to open up all the branches and see all the options, even though we don't want to write them down, and yeah, that's totally way too big. Hopefully this multiplication over here, when we just consider the first 2 steps, is something intuitive, but actually there is a mathematical principle behind that is called the fundamental principle of counting. So let me write it down. Fundamental principle of counting. And basically what it says is that if event 1 can happen in m ways, and then event 2 can happen in n ways, then the 2 of them, so event 1 followed by event 2, followed by event 2, this can happen in m times n ways. This is also sometimes called the multiplication principle instead of the fundamental principle of counting. By the way, the FPC in the title of the video is for the fundamental principle of counting. So, but going back to our problem, well, this we at least stated only for two events, like first one happening and then event 2 happening. And then we look at event 1 followed by event 2, like we pick the first letter and then we pick the second letter. But this actually applies for any number of events. In our example over here, after we imagine in our heads and we do not write the giant tree where we have 26 branches for the first case, and for each leaf at the end of the branch we have 26 branches more. Then for each of those new ones we're going to have 26 more. So actually we're going to multiply by 26 again, and then by 10, and then by 10, and then by 10. So the principle is the same. If we have k different events and we know how many ways each of them can happen, then the whole sequence can happen in as many as multiplying the ways for each of them. So let me write down. If there are k events, and they can happen in the first one in, let's say, n1 ways, the second one in n2 ways, and so on, and the last one in nk ways. So each of these n with a subindex, the n, it refers to the number of ways the event with the given subindex can happen. So for instance, in our example, event 1 can happen in 26 ways, event 2 can happen in 26 ways, same one for the third, and then they come the fourth, 5, and 6 can happen in 10 different ways. Then, this is the general, let me write, general fundamental principle of counting, so that then the k events, sorry, I have an extra letter there, the k events can happen in the product of the ways for each of them. So in n1 times n2 times all the way to nk ways. So this is the fundamental principle of counting, and it's very important, and I hope it's also intuitive. So we need to see how many ways we can make the different car plates. We need to find what is 26 to the power of 3 times 10 to the power of 3, and this is going to be a huge number. You need to do it with the calculator, and yeah, I don't care that much about the result. I cared here about the principle behind it.